Hi everyone, my name is Chang, C-H-A-N-G, and this is live streaming for OneClass. Today we're going to go over some common math problems asked in both the high school and the university level. So let's get started. Okay, our first question, or rather, our first concept is asking us about the binomial theorem. So let's do the binomial theorem. And I'm supposing that they're asking us to explain the concept of the binomial theorem. So let's first state the binomial theorem. The binomial theorem is a plus b to the power of n equals to the sum of k equals starting from 0. N choose k, a n to the power of n minus k, b to the power of k. And this is the binomial theorem. The a plus b here is called a binomial. This is because a and b, there are two terms. Usually we have a polynomial. The poly means that there are more than one or there are multiple terms, and the bi means two in Latin, so that means like a polynomial with two terms. So this is our polynomial, and this n choose k term is called our binomial coefficient, or I should use another color. Binomial coefficient. For those of you who haven't learned combination yet, n choose k is equals to n over k n minus k, where n is equals to n times n minus 1 times n minus 2 all the way to 1. So yeah, that's the binomial theorem. Now, let's look at an example of the binomial theorem. So actually, let's look at two examples. So first example 1, let's look at finding x plus 2 to the power of, let's say, 5. Okay, so this is our first question. Also, the binomial coefficient, n choose k, you can also find the binomial coefficient using the, I'm just going to move this down here. You can also find it using what's called the Pascal's triangle. So we would have, so each subsequent layer of the Pascal triangle is the sum of the two adjacent numbers. So in order to find a new layer of the Pascal's triangle, we would write another one on either side. And this number here would be the sum of the two above numbers. So it would be 3, and 2 plus 1 is 3. And we write another layer of 1. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And we write another layer of 1. And here 1 plus 4 is 5, 4 plus 6 is 10, 4 plus 6 is 10 again, and 1 plus 4 is 5. And we can use the Pascal triangle, or the number of input Pascal triangle is the value of n choose k, where k is equals to 1, k equals to, where n is equals to the layers, n equals to 1, n equals to 2, n equals to 2, n equals to 3, n equals to 4, n equals to 5, and the k is the index here. So for example, this will be the first index, the second index, etc., etc. So now let's look at finding the value of x plus 2 to the power of 5. So how do we do that? We know the a here is equals to x, and the b here is equals to 2. So like it will be x plus x is a, b is 2, and n would be equals to 5. b equals 2, n equals 5. So we know we need to use this layer of the Pascal's triangle. So let's just do, oopsie, Pascal's triangle. So now we know the first number here, 1, is just 1, and we know first we have the term a, n to the power of n minus k, so we have x to the power of n, which is 5, minus k, and k is starting from 0, so k is equals to 0, 5 minus 0 is 0, and then we have b, which is the number 2 to the power of k, and we know the number k is equals to 0, and 2 to the power of 0 is 0, so the first term is just 5. And the second term, we know we have n choose k, which is 5 choose 1. Now k is equals to 1, so we know we have 5 according to Pascal's triangle, and choose 1 is 5. And then we have x, a, which is x, and we have x to the power of n minus k. Right now, k is equals to 1, so 5 minus 1 is 4. And we have b to the power of k, which is 2, and to the power of 1 is just 1. And then next we have, let's just write all the n choose k term. We have 5 choose 2, x, which is a, n to the power of 5 minus 2, and then 2 to the power of 2. And then next we have 5 choose 3, x to the power of 5 minus 3, and then to the power of 3. Oopsie. And then we have 5 choose 4, x to the power of, because k is now 4, 5 minus 4, and then to the power of 4. And then we have 5 choose 5, 5 choose 5, x to the power of 5 minus 5, and we have 2 to the power of 5. And that terminates our terms. So this is equals to that. This is the complete form, and now we're going to simplify. So again, we have x5, or x to the power of 5, and we have 2 times 5, which is 10, and then x to the power of 4, and here we have 5 choose 2. From Pascal's triangle, we know 5 choose. We can also get 5 choose 2 using this formula, but from Pascal's triangle, we know 5 choose 2 is 5 choose 2 is 10, so we have 10 right over here, so we have 10 right over here, and then x to the power of 5 minus 2, which is 3, and then 2 squared is 4, so we have the third term is 40x cubed, and then we have x is equals to 5 choose 3, and then this is 10 again, so we have 10 is 5 choose 3, and then x to the power of 5 minus 3, which is 2, and then 2 to the power of 3, which is 8. And then we have 5 choose 4, and we know 5 choose 4 is 5 because this is the fourth term in Pascal's triangle. So we have 5, and then we have x to the power of 5 minus 4, which is just x to the power of 1, which is x, and then we have 2 to the power of 4, which is 32. And then next we have 5 choose 5, which is 1 according to Pascal's triangle. So it would just plus, and then x plus 1 times x to the power of 5 minus 5, which is another 1. And then we have 2 to the power of 5, which is 32. Oh, and here 5 to the power of 4 is actually 16. My fault. Here. So to simplify to the simpler forms, again we have x to the power of 5 plus 10 x to the power of 4 plus 40x cubed plus 80x squared plus 5 times 16, which is 80, I think. Or we can do a quick calculation here. 5 times 16, again it is 80. So we have 80x plus 1 times 32, which is 32. So this is the expression of x plus 2 to the power of 5. And that's how you use the binomial theorem to find information. And next, let's do a second example. And this example is about let's do an example about the binomial coefficient. The binomial coefficient So for example, we want to do we want to verify whether 5 choose 3 or whether 5 choose 3 here is indeed 10. So let's try to find 5 choose 3. And we're not using the Pascal's triangle because we already know from the Pascal's triangle 5 choose 3 is equals to 10. We're trying to use the formula here. So it will be n choose k is equals to, whoopsie, what's wrong with my notepad here? I'm just going to try to erase it. Okay, I guess we can't really do anything about it. Oh, perfect. So we know the formula from here is n choose k equals n factorial. Oh, by the way, this exclamation thing is called a factorial. So it will be equal to 5 factorial because 5 is n and k is 3 over k factorial, so 3 factorial, and then over n minus k factorial, so 5 minus 3 is 2, so over 2 factorial. And we know number factorial is a number times a number less than it, and then times a number 2 numbers less than that, all the way up till 1. So we know this is 5 times 4, or 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. And 2 factorial is 2 times 1. So in order to simplify that, we can cancel the 2 and 2 with the 2, cancel the 1 with the 1. And the 1 just, because anything over 1 is 1, so we can like cancel this as well. And we can cancel 3 with the 3, and we can cancel 2 with the 4, which remains 2. So our answer here is equals to 10. And we know that 5 choose 3 is 10, which is consistent with the answer we got from the Pascal's triangle. So yeah, that is all we're going to do with the binomial theorem. And let's look at the sample solution of right over here. So yes, binomial theorem. Binomial, again, this is a binomial. The term a plus b is binomial right over here. And yes, n choose k is equal to this. This is the binomial coefficient. Here should be a minus sign. I don't think you can see it very clearly from the photos, but it's all right. So yes, they did another example. Perfect. So it's a great job. The answer is correct. Might want to switch the binomial theorem image to show a clear minus sign. Cool, and the solution is correct. Now let's move on to our second question of this.